just like with ionic compounds, we find that it's more complicated, and we have to include, sometimes we have to include stock system. Well, we're going to see that with polyatomic ions and acids, because it can be more complicated. Right now, I just told you some basic polyatomic ions, no, and their relational acids, okay? But we're going to see that we can expand that and exploit what we've learned to. So let's before we go on, let's talk about this thing I'm going to call the hydrogen ion. And it's going to relate to what acids are. We will learn a property of an acid is that it gives off H plus when it is put in water. Okay. Now, technically, this is a 122 topic, but we will cover it a little bit of it here in 121. So let's look at what this H plus is, okay? Because a lot of times you'll see H plus and it just looks, you write down H plus. We will learn, or probably you already know, that hydrogen has one proton and usually has no neutrons. And you can look at the periodic table for that. So at the top left, is hydrogen, and its atomic number is 1, and that tells me how many protons it has. Okay. Usually when hydrogen is all by itself floating around with no one bothering it, it has one electron as well. So hydrogen is just usually a proton and electron. Okay, up to this point, we said that hydrogen behaves like a nonmetal. However, sometimes, okay, we included that like when we talked about covalent compounds. However, sometimes hydrogen can behave like other metals in the first column. Notice where it is in a periodic table. It's in the first column. And sometimes it actually can lose electrons. Just like sodium, lithium, and so forth. So let's look at sodium. What happens with sodium when it loses electrons? Sodium, when it's neutral, has 11 protons, 11 electrons. But when it's found in an ionic compound, it has a 1 plus charge. That means it's lost an electron. So now there's 11 protons and 10 electrons. So the net charge of sodium is 1 plus. And we write that as Na plus. So this means it has 11 protons and 10 electrons. Well, hydrogen does this as well when it's in acid, where the proton of hydrogen will leave the rest of the acid and its electron behind. So if you have like hydrochloric acid and you put it in water, what happens is the hydrogen flies off, but just the proton, okay, flies off, and it leaves its electron attached to the chloride. Okay, so technically what we can write this as H plus, because this proton came from H plus. Right, this species that has left is still a hydrogen atom, this guy right here. Has one proton, define its quantity. Okay, hydrogen is just one proton. And so there's a net charge of plus 1 plus. And so it's simply right is H plus, okay, which is essentially a proton. Well, it turns out we often exchange these three terms are interchangeable. Hydrogen ion, H plus, or proton, okay, all can refer to the same thing if you're talking about an acid. Okay, if you talk about a proton, as in like sodium's protons, you don't talk about it as an H plus. Only you talk about H plus and proton being equivalent when it's regarded an acid. Okay, polyatomic ions and acids that we covered. Two of the basic kind of polyatomic two of the basic kind of covalent molecules were polyatomic ions and tertiary acids or acids. You saw that actually they are not mutually exclusive. Polyatomic ions were essentially tertiary acids without an H plus. Okay, so if you go back and look at nitric acid, I'll show it in the table below. Nitric acid is HNO3, okay, but nitrate, its corresponding polyatomic ion, is NO3 minus. Well, where's this guy? Well, to become this, it lost an H plus. Okay, so here's the four that we looked at. So sulfuric acid became sulfate, lost 2 protons. So 2 H pluses. Okay, carbonic became carbonate, lost 2 protons. Phosphoric acid becomes phosphate, loses 3 protons, and nitrate loses 1. When we look at the corresponding acid and its polyatomic ion, the number of the charge of the polyatomic ion is the number of hydrogens in the acid. And that's because the hydrogens leave, will take its proton and leave the electrons behind. So when the hydrogens, these 2 hydrogens leaves a sulfate, they leave their 2 electrons back with the sulfate. That's why it becomes 2 minus, and the 2 protons fly off. Phosphoric acid has 3 hydrogens, and it can lose all 3 of those. Okay, and there'll be 3 hydrogen ions flying around. All right, here's a whole bunch of polyatomic ions. Okay, and they all do the same thing. I don't know. You can go here. Oxalate. All right. Well, oxalate, we're going to see in a minute, was oxalic acid. Okay, and it's 2 minus, so the acid would be H2C2O4. And so we could figure out the chemical formula for the associated acid given the polyatomic ion. You won't have to memorize these. You will be given a chart. There are some things that I'm going to go over that you need to know. But if there's some weird ones like azide or silicate, okay, or permanganate, I will give you those chemical formulas. All right, 8 and 8. Okay, so what we're going to go over now is, so far we've seen things called like nitrate. Okay, if you look at the previous table, you'll see that there's something called nitrite. Okay, they're kind of alike but different. All right, you'll see sulfate and sulfite, nitrate, phosphate, and so forth. Let's look at this 8 and 8 thing. Okay, phosphate is PO4 3 minus. Phosphate is PO3 3 minus. Notice the difference is that's the number of oxygens. Okay, sulfate is SO4 2 minus. Sulfite is SO3 2 minus. Okay, the species with the most oxygens is called 8. The species that have 1 less oxygen is 8. So if you know nitrate, NO3 minus, nitrite would be 1 less oxygen, NO2 minus. Nothing else changes. Okay, the nitrogen and the charge doesn't change. Okay, so this is actually similar to the stock ions in terms of the naming. Ick, the ick and us relationship. Ick from the when we, like the copper 2 plus, I told you was cupric. All right. Okay. The 8s, all right, like phosphate. Okay, PO4 is 8s. So most oxidative states will sometimes end in ic and sometimes in 8. The less oxidative states, if it's ic, it will be the opposite. The less oxidative state will be us and ite. And you're going to see this in a second. All right. So how this relates. Okay. Expanding acid naming. We saw that polyatomic ions from ic acids end in 8. They're like phosphoric acid become phosphate. What are the ites? Do they become ics? No, they become us acids. So sulfate, when it loses its hydrogens, it becomes us, the less oxidative state. Okay, so so we saw that. Okay, less oxidative state. So here's kind of a weird way to remember it. I ate something icky. So the 8s and icks. And Sprite is delicious. So the ites become us. So let's return to the old time naming of ions. Remember cupric and cupris. And cupric was the more oxidized state. Well, if we look at the acids, we have sulfuric acid and sulfurous, okay? And we said the ic is more oxidized. Well, sulfuric acid is more oxidized, has more oxygens, and a sulfurous has less oxygens. Okay, so that's, I don't know if this will help you remember stuff, but that's kind of how it all ties together. Chlorate family. Okay, the chlorate family is kind of an interesting one because it's got a lot of stuff going on. So if you look on the table a few pages back, you'll see that there's hypochlorite, chlorite, chlorate, and perchlorate. Okay, so let's start out with chlorate, and I know this information. I know it's ClO3 minus. Let's say I give this to you. All right. Since it's 8, it's got to be an ic acid. And it's be HClO3. It has 1 minus, so it has 1 H. Okay. Now, if the polyatomic ion has 1 less oxygen, it becomes ite, chlorite, and its acid becomes chloris. Or HClO2. Again, only 1 H because, so the only thing that changes is the H. Okay, now it turns out that it could be even one more less oxygen. Okay, so now this can be ClO minus. Okay, and what we do is we put a hypo in front of the chlorite. Okay, so hypo means under, so it's 1 less than chlorite. So ClO minus. And the acid would be hypochlorous acid. And it turns out that the chlorate can have 1 extra oxygen. So it's chlorate, and adding 1 is like hyperchlorate, but we just say perchlorate. And so it's going to be ClO4 minus, and this should be perchloric acid. Okay, now we learned, and with the common covalence, there was something called hydrogen peroxide. Hydrogen peroxide is H2O2. Okay. Okay. And what it is that it's called peroxide because this is the maximum of oxygens that a hydrogen oxygen compound can have. So per means most abundant, most amount of oxygens can have. Finally, the last thing, if you go back and look at the chart, you'll see, you may see things like phosphoric acid, dihydrogen phosphate, mono hydrogen or hydrogen phosphate, and phosphate. All right. So, so when you have phosphoric acid, what happens is that not all three of the hydrogens can come off at one time. They actually come off separately. So when the first one comes off, you end up with something called dihydrogen phosphate. I hope that makes sense here. Then monohydrogen phosphate, and then phosphate when it loses itself. Okay, so if you go back and look at the table of polyatomic ions, hopefully you'll see how all that sort of connects. Right, and you'll be given a worksheet to deal with this one as